All right, so today we start talking about graphing quadratics. And the first day here, we're going to talk about graphing quadratics that are in standard form. It's a little bit of a process, but this is all from Algebra 1. We did all this in Algebra 1, so hopefully some of those memories will come flooding back. So we want to be able to identify and graph quadratic equations today in standard form. We'll talk about vertex form next time. Okay, so things you need to remember. Quadratic function. The graph of a quadratic function is called a parabola. It's that U, right? Looks something like this or like this. There is a parent function for this family, just like there is for any, and that parent function is y equals x squared. The standard form for a quadratic function is y equals ax squared plus bx plus c. A is always next to the x squared. B is always the coefficient on x, and c is always the constant. Now, these U's, they have a lowest point or a highest point, depending on how they open. And so that's what's called a vertex. The vertex on the graph can be found using a formula, right? And we use this in Algebra 1, but it's the formula opposite b over 2a. And we pull those from your standard form here, okay? Now, the opposite b over 2a is the same process that we use to find the axis of symmetry. What the axis of symmetry is the line that cuts the parabola in half, right? A parabola is symmetrical. It's the same on the left side as it is the right side. And so this axis of symmetry is going to cut it in half. Since it cuts it in half, the axis of symmetry, like right through here, is going to go through that vertex. So it shouldn't be surprising that whatever that equation is for the axis of symmetry, that's going to help us get the x-coordinate for our vertex. And we'll see that some more in just a minute. Okay? All right. Now, we went through an activity on a website called Desmos before to find out how some of this, how A affects things, right? So again, we go back and A is the coefficient on x squared. As A changes, that helps describe how the parabola is going to look, what it's going to look like. Excuse me. What we found through that activity is that as A is positive, then the parabola is going to open up. If A is negative, the parabola is going to open down. Now, as the number itself for A, take this sign away, so the absolute value of A, as it gets bigger, right, bigger than 1, and it keeps climbing, then the parabola will get thinner and thinner and thinner compared to the parent function, y equals x squared, okay? Now, in the A for the parent function is 1. So if A gets bigger than 1, then that parabola is going to get thinner, thinner, and thinner. If A ends up between 0 and 1, right, or gets smaller, so fractions, decimals, and keeps getting smaller and smaller, then the parabola is going to get wider. Okay? So those are some ways that we can kind of get an idea of what the parabola should look like when we start graphing. All right, so compared to the parent function, whose A is 1, how are these graphs going to differ? How are they going to be different? Well, the first one, you see that the A is negative. So this guy's going to open down, where the parent function is going to open up. And because its A is negative 2, so the number is 2, since the absolute value of negative 2 is 2, and 2 is bigger than 1, then this graph would be thinner than the parent function. Number 2, A is positive. So that means that this graph's going to open up just like the parent function. So it's not going to be different in that way. They're going to be the same. But A is a fraction, 2 over 7. That tells us that this graph is going to be wider than the parent function. Last but not least, number 3, since A is negative, this parabola is going to open down. And because it's a fraction, compared to the parent function's 1, this guy is going to be wider. Okay? So that's how we use A to kind of give us some idea of what the parabola is going to look like. Okay. Now we got to practice finding the vertex and the axis of symmetry. Okay? We said that for the axis of symmetry, which is probably easier if we find that first. That formula is x equals opposite b over 2a. So what's b? Well, b is negative 2, c is negative 1, a is 1/2. So we're going to go opposite of b. So opposite of negative 2 would be positive 2. Then we go 2 times 1/2. Because a is 1/2. So we get 2 over, 2 times the half is 1. So our axis of symmetry is that x equals 1. Axis of symmetry is a vertical line, and so therefore always needs an equation to describe it. So we're going to draw a vertical line through 1. That vertical line is also going to cut our parabola in half. The vertex then has to sit on the axis of symmetry. In order for that to happen, the x-coordinate has to be the same as the number, as what the axis of symmetry equation is equal to. So the x-coordinate for the vertex is going to be 1. To find the y-coordinate, we just kind of go back into plug and chug mode. We plug 1 in for x and see what we get for y. Excuse me. So 1 squared is 1. You get 1/2 times 1, which is 1/2. Negative 2 times 1 is negative 2, and then minus 1. So a half minus 2 gets you negative 1.5. Negative 1.5 minus 1 is negative 2.5, or negative 2.5. For graphing purposes, putting this in decimal form probably makes more sense. Okay? So that's how you find the vertex and the axis of symmetry. Okay? Another one here. The axis of symmetry, again, comes from taking opposite b over 2a. Opposite of b is negative 8, because b is 8, c is 2, and a is negative 4. And so 2 times negative 4, because a is negative 4, gets you negative 8 over negative 8, which is 1. So x equals 1. Since the vertex has to sit on the axis of symmetry, the x-coordinate for the vertex has to be 1. To find the y-coordinate, just plug 1 in for x and work it out. 1 squared is 1. 1 times negative 4 is negative 4. 8 times 1 is 8. So you get negative 4 plus 8 is 4. 4 plus 2 is 6. So your vertex is at 1, 6. Okay? It's just a formula opposite b over 2a that you're going to have to memorize. All right. How does that get us into graphing? Okay? Well, as we find the axis of symmetry and vertex, we need to do a couple more things to get us to know exactly what the shape of the graph is going to be. So for this equation, for this function, y equals 1/2 x squared minus 2x minus 1. Again, a is 1/2, b is negative 2, c is negative 1. So when we do opposite b over 2a, and I'll do it again even though we just did it, opposite b is positive 2. Then we go 2 times 1/2. 2 times 1/2 is 1, so we get 2 over 1. So the axis of symmetry is x equals 1. That's a vertical line that goes through 1 on the x-axis. So the vertex is going to sit somewhere on that vertical line. Well, anywhere on this vertical line, the x-coordinate is always going to be negative 1. That's why we always pick up whatever the axis of symmetry is equal to as the x-coordinate for our vertex. So 1. Excuse me. So we're going to plug in 1 for x in the original function, and that'll help us find what y-coordinate is for the vertex. 1 squared is 1, times a half is a half. Negative 2 times 1 is negative 2 minus 1. And this should sound very familiar because we just did this. And this should be negative 2.5. So our vertex is at 1, negative 2.5. So let's go plot that. 1, negative 2.5 puts us about right there. Okay, now, we have to have some more points to have some idea of what the graph looks like. So we're just going to do the t-chart method. We're just going to plug in some x's into the function, find out what the y is that goes with them, and plot those points. You can choose any x's that you want, as long as the two x's that you choose are on the same side of the axis of symmetry, and two, choose them to where that your life's going to be a little bit easier. I'm definitely going to choose 0 anytime I can, because when I plug in 0, the math gets really easy. 0 is on the left side of the axis of symmetry, so I need another number, another x on the left side that makes sense to plug in. And since a is 1/2, since it's a fraction, I'm going to choose a multiple of 2. I'm going to choose a multiple of the denominator, because if I do that, then the fraction will multiply out, and I don't have to worry about doing math with fractions. Excuse me. And so since I want to be on the same side of the axis of symmetry, and I want to be a multiple of 2, I'm going to choose -2. All right, so if you plug in 0, this becomes 0, this becomes 0. And so we just get -1 for y. Now when you plug in -2, it gets a little bit more arithmetic heavy. So let's go do that. -2 squared is +4. -2 times -2 is +4. Half of 4 is 2. 2 plus 4 is 6. 6 minus 1 is 5. So here are some more points. 0, -1. So 0, -1 is right here. And then -2, 5. And because this parabola is symmetric, we just mirror these on the other side. Reflect them over the axis of symmetry. And you can draw on your parabola. It opens up, which makes sense because A is positive. So use A to help you figure out if you're graphing correctly. Now, we got to talk about domain and range. Domain and range are a lot like what we did for the absolute value graphs. This parabola does go up, but it also goes out. It goes up and out. So domain are your x's. And the question is, what values along the x-axis is the graph going to cover? And since those ends go out as well as up, they will eventually get to -infinity and infinity on the x-axis. So the domain is -infinity to +infinity. As a matter of fact, it always will be -infinity to +infinity. Okay? Now the range is the y-axis. What values on the y-axis is the graph going to cover? And we want to look from bottom to top, right? The y-axis goes this way. We want to go from bottom to top. Well, obviously the graph, since it doesn't open down, is not going to go to -infinity. So our range isn't going to start, the bottom isn't going to start until we get to this level right here. And that level on the y-axis is -2.5. So we want to go from -2.5, and since it opens up to +infinity, we're going to go up to +infinity. That's going to be the top. So that's our range. Okay? A little bit of work, but that's what we got to do to get this guy graphed. All right? Let's do another one together, and then I'll try to have you do a couple on your own. Okay. So axis of symmetry again. We've got a formula for that. That's x equals opposite b over 2a. A is 3, b is -6, c is 4. So we go opposite of b, which is +6, over 2 times a, which is 3. So 1. So x equals 1 is the axis of symmetry. So again, we can draw a dotted line through 1 on the x-axis. We know the vertex is going to sit on that axis of symmetry. So the vertex x-coordinate must be 1. To find the y-coordinate, we plug that in. One squared is 1. 1 times 3 is 3. -6 plus 4 gets us +1. So the vertex is at 1, 1. Right there. Now, we want to pick two more values to plug in for x. So we're going to pick two more x's, plug those in, and find out what the y's are so we can create two more points. Again, use your head. Make the life easy. I want to plug in 0 as long as 0 is not on the axis of symmetry. So I'm going to use 0, and I'm going to use -1 because I want to be on the same side of the axis of symmetry, but use a number that's easier to plug in. If I plug in 0 for x, those are going to go to 0, and I'm just going to get +4. If I plug in -1 for x, it's a little bit more complicated than that. So do the arithmetic. -1 squared is 1. 1 times 3 is 3. -6 times -1 is +6. And so this is 13. So -1 comma 13. So let's go plot those points. 0 comma 4. -1 comma 13 has you off the grid a little bit. That's okay. Then we're going to mirror image these. So something like that. Okay? Our domain is always -infinity to +infinity. Our range needs to be written from bottom to top. The bottom of the graph starts at 1 on the y-axis. The top of the graph goes all the way to +infinity. So there's our range. Okay? Hopefully that makes sense. If not, you got to come in and see me and we'll get it figured out. Couple more for you here. Before we do 8, I'm going to skip it and have you try 9. 9 doesn't have a fraction in it, so shouldn't be as weird. So go ahead and graph 9. Stop the video, start it back up, and see how you're doing. Okay, so I'll walk you through this. Axis of symmetry. X equals opposite B over 2A. Opposite B is -8. 2 times -4. Because this is A, this is B, this is C. Get you -8 over -8, which is 1. So x equals 1 is the axis of symmetry. The vertex has to sit on the axis of symmetry, so the x coordinate is 1. To find the y coordinate, we're just going to plug it in, plug 1 in for x, and see what y is. 1 squared is 1, times -4 is -4, plus 8 plus 2, get you 6. So 1 comma 6. All right, let's go draw those in. So x equals -1 goes down through like this, and then 1 comma 6 puts you right here. All right. Now we got to choose a couple more x values to try. Again, 0 is not on the axis of symmetry, so I'm going to try that. And I'm going to plug in -1 because it's on the same side of the axis of symmetry and shouldn't be a whole lot tougher. Plug in 0 for x, and all those guys are going to go to 0, so you get 2. Now plug in -1 for x. We get -4 minus 8 plus 2. Let's get you 10. Sorry, -10. So we go 0 comma 2. 0 comma +2. -1, -10. And then we mirror image on both sides. And boom, we're done. Domain is always -infinity to +infinity. The range from bottom to top. The bottom goes all the way down to -infinity, so we want to start there. The top caps out at 6 on the y-axis, so 6 ends our range. Okay? All right. There's one more that I wanted to walk you through. So let's take a look really quick. And I wanted to do it with you because of that a being negative 1/3. Right? So, all right, same process, axis of symmetry. We got to get that from going x equals opposite b over 2a. Opposite b is negative 2, and a is negative 1/3, sorry. So, we get negative 2 over 2 times negative 1/3 is negative 2/3. And then dividing by a fraction is the same as multiplying by the reciprocal. So we want to take negative 2 times negative 3 over 2. And that gets us positive 6 over 2 or 3. So x equals 3. The vertex, the x coordinate is going to be the same. It's going to be 3. And then we got to plug in to find out what the y coordinate is. And we got to do a little bit of arithmetic with some fractions. So, all right, negative 1/3, 3 squared is 9, plus 6 minus 6. Negative 1/3 times 9 gives you negative 9 over 3, or negative 3. 6 minus 6 is 0, so it's just negative 3. So the vertex is at 3 comma negative 3. And the axis of symmetry goes right through it. Okay. Now, we need 2 more values of x to plug in. And I'm definitely going to try 0 still, because it's easy. And then because a is a fraction, I need to choose another x that's a multiple of 3. That way the fraction will multiply out for me, and I don't have to worry about adding fractions up, okay? So when I plug in 0 for x, these guys go to 0, and we get negative 6. Now, a little space for the work here. And I'm going to choose negative 3 as another value to try. Okay, it's on the same side of the axis of symmetry as 0, and it's a multiple of 3. And so the fraction will multiply out. Okay? Now, negative 3 squared is positive 9. Positive 9 times negative 1/3 gives you negative 9 over 3, which is negative 3. Now, 2 times negative 3 is negative 6. You have negative 6 here again. So you combine those, and you get negative 15. Okay? All right. So 0 comma negative 6. And since that point is 1, 2, 3 spaces from the axis of symmetry, we go 1, 2, 3 spaces away from the axis of symmetry on the other side, and we can mirror image those points. And then negative 3 comma negative 15. 1, 2, 3, 4, 5. We have to kind of fudge it a little bit because we're a little bit off the grid. But that is 6 away from the axis of symmetry. So we go 6 away again, and we mirror image that point. And this becomes our parabola. Okay? So there you go. A little tougher with some fractional arithmetic, but it's the same process. Domain is negative infinity to positive infinity. Our range, our bottom goes all the way to negative infinity. And our top tops out at negative 3 on the y-axis. So that's our range. Okay? So there's graphing in standard form. We'll do vertex form next time. All right, homework's out in Canvas. Get that guy knocked out.